In this video, we are going to solve a problem involving the midpoint of a line segment. It's given that a straight line with an unknown k and a circle intersect at 2 points, P and Q, and the x-coordinate of the midpoint of PQ is 0. A diagram may not be necessary if we are solving this problem algebraically, but it can still help us visualize the problem. So let's still sketch it out. The equation of the circle is given as x squared plus y squared minus 4x minus 2y minus 11 is equal to 0. So the coordinate of its center are 2, 1. Mark the approximate position of the center and sketch a circle. Now the straight line x plus y is equal to k. From its equation, we get that its slope is negative 1 over 1, that is negative 1. So it's a line sloping down from left to right, and it intersects a circle at P and Q, with the midpoint of PQ on the y-axis. So the straight line is maybe like this. To find the value of k, which is a constant term of the equation of the straight line, what can we do? Given two equations, we can first set up a set of simultaneous equations and then obtain a quadratic equation in x. The roots of this quadratic equation will be the x-coordinates of P and Q. Let's denote the coordinates of P and Q as x1, y1, and x2, y2, respectively. Then the x-coordinate of the midpoint of PQ will be equal to x1 plus x2 over 2, and it will be equal to 0 since it's given that the x-coordinate of the midpoint of PQ is 0. Then what? Does x1 plus x2 remind you of anything? Yes, the sum of roots of a quadratic equation. And if this sum of roots involves k, then we'll have an equation in k. Let's see if this is the case. Write down the simultaneous equations, then make y the subject of the equation of the straight line and put this into the equation of the circle. This will make the equation a bit complex, so be careful when simplifying it. Eventually, we will obtain a quadratic equation in x and the unknown k. Recall that for a quadratic equation, ax squared plus bx plus c equals 0, the sum of the roots is negative b over a. So, the sum of the roots of this quadratic equation is negative 2k minus 2 over 2. We've said that this is the sum of the x-coordinates of P and Q. Multiply it by 1/2 to get the x-coordinate of the midpoint of PQ, which is equal to 0. Here we go, we've got an equation in k. 0 is equal to k plus 1 over 2. Solving it, we find that k is equal to negative 1. Alternatively, we may try to use a property of circles and the relationship between perpendicular lines to find the results. Let's denote the midpoint of PQ as M, whose x-coordinate is 0. Putting x is equal to 0 into the equation of the straight line, the y-coordinate of M will be k. Let's call the center of the circle G. And we found its coordinate earlier, which are 2, 1. Then, since PM is equal to QM, the line passing through M and the center G will be perpendicular to the chord PQ. Therefore, the product of the slopes of PQ and GM will be negative 1. The slope of PQ can be obtained from its equation, which is negative 1. The slope of GM is 1 minus k over 2 minus 0. The product of the two is equal to negative 1. Solving it, we can still get the same result. K is equal to negative 1. That's it.